Hello friends, welcome to my channel Civil Structures. Let's see the definition for determinant structure, the structure for which the reactions at supports and the internal forces in the members can be found by the conditions of static equilibrium is called a statically determinate structure. Indeterminate structure, the structure for which the reactions it supports and internal forces in the members cannot be found out by the conditions of static equilibrium is called as statically indeterminate structure. As per the definition, there are basic three static equilibrium equations. They are f of x is equal to 0, f of y is equal to 0 and moment in z direction is equal to 0. So these three static equilibrium equations for the 2D structures. Structure can be said statically indeterminate externally and internally. External stability depends upon the support of the system and internal stability depends upon the configuration of joint of the structure. The degree of static indeterminacy is equal to the total number of unknowns in system minus number of independent equilibrium equations. So as we discussed previously that the static equilibrium equation for 2D structure is 3. Okay, and if we want to discuss that total number of unknowns, it may be in terms of external and internal. Okay, so let me just write degree of indeterminacy externally plus degree of indeterminacy internally minus we have to reduce the releases. Maybe there are some internal hinges in our system. Okay, so these all just come under this total number of releases. Okay, so as per my equation I can write let me just ds is equal to de plus di minus r. So de is equal to external indeterminacy di is equal to internal indeterminacy and r will be the total number of releases. Now let's talk about external indeterminacy of structure. Okay, so as I told you, it depends upon the type of support. It is related to the support. Okay, so we know that we generally use different types of supports in our system. It may be free end support, it may be roller support, okay, it may be hinge support, then fixed support, and last we are using here vertical girders. Okay, so our reaction component as per the supports for free end, let's say I'm just drawing a cantilever beam. At one end it is fixed support and the other end it is free. So at free end it will having 0 number of reactions. Now let's talk about roller support. Okay, you can see I just provide roller support at this end. Okay, so here you can get only vertical reaction. Okay, so I can just write the reaction for roller support is 1. Okay, now hinge support. So you can see this is a hinge support I just provided here, and for that vertical support and 1 horizontal reaction will be there. So hinge support there will be 2, and for the fixed support if I'm taking at this end, my fixed support reaction will be total 3, vertical, horizontal and 1 moment, and fixed support the reaction are 1. Okay, and let's talk about the vertical girder, and they might be look like this vertical girder, and they will provide us 2 reactions, horizontal reaction and 1 moment. Okay, so let's write vertical girder will give you 2 reactions. Okay, and how the degree of external indeterminacy, we can write the reactions minus static equilibrium equations. So number of equilibrium equations. Okay, now when we talk about internal dE, it's about dI. So for different structures, for beams, for truss and for frames, there are different formulas related to dI. Generally for beams your internal indeterminacy will be 0, and for truss and the frames I will explain you in my further lectures. Now let's take some beams and calculate the static indeterminacy of these beams. Okay, so let me take first example. My first example is this type of beam. You can see at one end it is fixed and the other end it is hinge. So if I want to draw the reactions for this particular beam, as we know that fixed support will give you 3 reactions, hinge support will give you 2 reactions, and how we have total number of reaction will be 5. So let's write first the basic equation. ds is equal to dE plus V of I minus R. Okay, so about external dE, it is total 5 number of reaction minus basic equilibrium static equation. So it is 2D structure and it will be 3. So dE will be 2. Okay, Now let's talk about DI, and I just told you that DI for beam will be 0, and you can see we don't have any type of internal hinges, so we don't have any type of releases, so R will be 0, and I can just write your D value will be 2 plus this is 0 minus release will be 0, and finally it is 2. So I can say that this beam is 2 degree of statically indeterminate. Okay, if you say, I can just write at second degree statically indeterminate structure. Okay, now let's take second example. Okay, and for this again we just write our basic equation, ds is equal to de plus di minus r. Okay, and my de will be, you can see this hinge support will give you only 2 reaction and roller support will give you 1 reaction, so we have total 3 reactions, and we have 3 static equilibrium equation. It will be 3 is equal to 0. Okay, and di will be 0, and of course we don't have any type of hinge here, internal hinges here, so R will be 0, and finally I'm just getting 0 plus 0 minus 0 is equal to 0. So this is statically determinate structure. Okay, now let's take third example. Okay, so as per the diagram we can easily understand that this is a fixed support and it will give you 3 reactions. This is a hinge support, it will give you 1 reaction, otherwise it is give you 1 reaction. And let me just write the basic equation, which is ds is equal to de plus di minus r. And if we talk about particular de, and it will be the total reaction. How many reaction we have? 1 2 3 4 5. 5 minus 3 is a basic static equilibrium equations, and it is 2. Then the value of di is 0 and r is 0, so you can just write 2 plus 0 minus 0 is equal to 2. So similarly you can get just idea that this beam is statically indeterminate for second degree. Okay, better idea. Let's just take other examples, and I'm just taking fixed beam, and we know that fixed beam having 3 reactions. Okay, so let's just calculate. The basic equation is ds is equal to de plus di minus r. You can see I don't have any releases here, so the r value is 0, and the de will be 6, which are the basic equation, minus 3 plus di is 0 minus r is equal to 0, and it will be 3 plus 0 minus 0, and finally it is 3. And so my structure is, or maybe I can say this beam is statically indeterminate up to third degree. Okay, now let's take some examples which where the beam having internal hinges. Okay, so I'm just taking a beam which is a fixed beam, and it is having 2 internal hinges. Okay, so as per your basic idea, I'm just writing internal hinge, Okay, so better IH is equal to internal hinge. And as far as my knowledge, you know that at internal hinge your bending moment will be 0. So you can just determine the reactions as external indeterminacy is depend upon the support, and as per the support my indeterminacy, which is DE, is equal to 6 minus 3 is equal to 3, DI is equal to 0. And now let's talk about R. You have total 2 number of internal hinges. So when you calculate R as in releases or internal hinges, you just have to consider, or I'm just telling you equation related to that, and you have to take M minus 1. What is M here? Where M is equal to the members connected with internal hinge, number of members connected with internal hinges. Okay, so for this particular example we have total 2 internal hinges. Okay, so you can just see that this is my first internal hinge. I have 2 beams or 2 members connected with this first internal hinge, so I'm just writing 2 minus 1. But I have another hinge, this, so we have to add this internal hinges releases. Okay, again the same, there are two members connected with this hinge, and it is 2 minus 1. Finally 1 plus 1 is equal to 2. So if I want to write the basic equation, which is ds is equal to de plus di minus r, where your de is equal to 3 plus di is equal to 0 minus r is equal to 2, and you have total 5 degree of internal it will be 1, and your structure is statically indeterminate at first degree. Let's take one another example. Okay, I have a beam having hinge, then here I am having internal hinge, again internal hinge, okay. So if you say, I am just starting with writing the basic equation, ds is equal to de plus di minus r. Okay, so as we know that di will be 0, so we can just start with de. So how many reactions we can find in this beam hinge support? There are 2 reactions where it is a hinge support, and you can find 2 reactions, and it is a roller, you can find 1 only, and the total reactions are 1, 2, 3, 4, 5. Okay, we have static equilibrium equation R3 for 2D structures, and D will be 2. And now let's talk about release. So how many hinges we have? We have total 2 internal hinges. Okay, and as per our formula I just told you, you can just write m minus 1 for each hinge. Okay, so if I take you can just see, this is my first hinge and 2 members are connected, so it is 2 minus 1 plus again 2 minus 1, you can see for this hinge one member and the second member, and finally 1 plus 1, and it is 2. And the final answer of DS is equal to 2 minus 2 is equal to 0. So this beam is statically determinate. Okay, so I think these examples are enough to understand the static indeterminacy of beam. Okay, now we'll see for frames and for trusses next time. Thank you.